Now I've loaded the application on the screen, primarily two windows. First is the mapping window, the second is the video window. Either window can be expanded to the full width of the screen. So there is the video window expanded, and there is the map window expanded. Once the window is expanded, you can search through, look around on the window. The system has got normal video controls at the top here, and those video controls allow playing of the video. And so now you notice the video is in motion, and over here on the moving map, the position of the train as it progresses through the map. The map in this case is a standard scheme plan, and what can happen also is that as you switch to the panning map and you click a position on the panning map, it will go there. So if you're interested in looking at this AWS ramp, you could click on it and there it is, it comes up in the video. Other maps we've got are a moving driver map. Again, if we rewind the video, restart, so we start off in Palmer's Green Station and we move along the driver map on the right hand side. And then lastly in here is a sample only, but it shows signal sighting forms. If you want to attach documents to particular locations, you could, for example, find a signal like this one, K841, and in here the signal sighting forms could appear. You can sort of look through and scan and see what's been said on that. The video is high definition, 50 frames a second, and you can move through the video. You hear that we have audio recorded as well, and as we move through the video we can pull up to a particular signal and we're able to see the actual frame number that we're on, frame 699 in this case. Now, down on the bottom line here we have the trace data, and this is the trace collected from the train during the run, so it's a geopositional trace. And if we hit measure at the top of the screen here, measure, it zeroizes the counter down here. We can look at the signal on the scheme plan. Just to mention also that this is a zoomable map, and I've zoomed it up so you can see in the top the distance to the next signal on the scheme plan is 422 meters. So now we'll progress down the track to the next signal, which is K843. And as we pop down the track, we will come to the next signal. When measuring, we overrun and just pull back to the base of the signal, and then we will see that on the measuring line at the bottom of the signal we've got a measurement of 420.82 metres, so the accuracy is dependent on the accuracy of the trace you collect. This is augmented sat-nav data, and so we're within 1 metre, just over a metre of accuracy over quite a long distance. So on shorter distances obviously the accuracy will be better. So now I've got the measuring window opened. Again, we're going to measure the distance back from the signal to the AWS ramp. And just pull it back to the measuring line, so that the measuring line is at the base of the signal, and then zeroise the measure, and then backwards up the track to the AWS ramp. Pull that back up to the sighting, and we've got about 207 metres in this particular case for the AWS ramp, about 206, 207 metres. Of course we can see the ramp on the measure, we can see the signal down, the sighting of the signal down through the bridge. So the driver can see that as it goes round. It's quite interesting to see the signal as it progresses through the magnifier, that it's in visual contact with the driver for the whole way round the curve. It's a good thing to confirm by the placement of the signal. And we go to the centre of the signal and click. We draw down to the base of the signal to get the signal sighting height. Click. Having done that, we can actually enter the label of the signal, which is K843, and that measurement is stored. Look at the measurement history on the screen. And we can actually see that we are recording a history. We can actually show a picture of that measurement, which comes up in the paint package, as you see on the screen. That's stored along with the measurement that's been taken. Also the detail of the measurement and the distance recorded, and that's how the measurement facility operates. Okay, second measurement can be taken. Again, do a bit of distance measuring. Rearrange the magnification window so that it's very clear what we're doing. Okay, so we're distance measuring. We're going to go from the bottom of the signal to the edge of the rail, and then we'll say distance 1, and next measurement, we'll measure the gauge of the rail. And having measured the distance, we can see that it's given us a figure of the track width at 1434.22. There is obviously an aspect of accuracy of the use of the screen, but it's made much easier by the fact that you've got the zooming magnifier in there. Obviously distances of all kinds can be stored in history, and at any point you can copy it to the clipboard or to an Excel spreadsheet, clear out the history, or actually show the image of what you've measured and store that too. We can record from service trains, we data record high def video, sat-nav trace. The application will display the film, the trace data, the scheme plan data, the signal sighting forms, the driver map. We can measure on screen distances of any kind and areas. The measurement is stored. The user applications like Excel, spreadsheets, etc., and shots of the measurements are recorded. We can deliver this on DVD, USB stick, or an hard drive for playing on any good Windows PC or server. It's called the Route Survey Tool, part of our Intelligent Track Survey product range. Thank you.